We studied the vocabulary word, well, in our vocabulary lesson we studied the term equivalent expressions a little bit. And you know, most of you know that equivalent means equal, and expressions are just math problems. When we talk about expressions, they don't have an equal sign, an expression, but we can set expressions equal to other expressions. I don't want you to take notes just right now. I'll tell you when to get them set up. But we're just going to look at Explore activity number 1, identifying equivalent expressions. One way to test whether two expressions might be equivalent is to evaluate them for the same value of the variable. So evaluate means to get the answer. You don't have to write this down. We're just talking about vocabulary. Get the answer. So get the answer for and use the same value of the variable. That means that everywhere you see an x, you're going to put in the same number. Okay, so A says evaluate each of the expressions in the list for x equals 3. I don't know why they say the word for. I think they should use the word when x equals 3. So here, and let me change my color here real quick. Change it to red. Up here, when you see that 5 right next door to that variable x, that means that you're going to multiply. Let's see where else there's letters and numbers right next door to each other. There's one. That means to multiply. There's another one. Okay, here's one. All of those are multiply. This also is multiply right here. That means that you're going to work inside the parentheses and get that answer and then take it times 5. Same thing here. Work inside the parentheses to get the answer and then take it times 5. So remember, we're taking out x and putting 3 for everything. So 5 times 3 is 15. Add it 65, that's 80. Okay. Right here, 3 plus 1 is 4. 5 times 4 is 20. And then here, 5 times 3 is 15. 1 plus 15 is 16. Let's look at list B. That's 5 times 3, which is 15, plus 1 is 16. 5 times 3 is 15 plus 5. 15 plus 5 is 20. Let me write that on there. And then here, 13 plus 3 is 16. And 5 times 16, I don't have that memorized, is 80. Okay, so which pairs of expressions have the same value for x times 3? So we would say, let's start with this one here. 5x plus 65 was 80, and that's equal to this one right here. Okay, so we can say 5x plus 65 is equal to 5 times 13 plus x. Okay, and then this one right here, 20, matches this one right here. So that's right here and here. 5 times x plus 1 is equal to 5x plus 5. And then the last one was these two. Okay. So this question, how could you further test whether the expression in each pair are equivalent? You could try a different number. I'm going to write this in cursive so you can get used to seeing it. You could try a number other than 3. They're out there looking for Max. Max ran away. Do you think the expressions in each pair are equivalent? Why or why not? Do you think the expressions in each pair are equivalent? I don't know what that's asking. Okay, skip. I want you to just continue just watching for now. You don't need to take notes on this. Okay, I'm just getting you used to what some of these things are going to be. When you see that, that means positive 1. And when you see that, that means negative 1. And then the long tile with the positive sign on it is just a number that we don't know. Okay? So usually I don't know why they put a plus sign there. That should be X. Okay? So let me delete that X right there. All right, so here we have X plus 2. Okay? And there's 3 groups of those. So here's X. Remember I said those should be X's. I don't know why they put plus signs there. There's one group of it, there's another group of it, and there's another group of it. Here we have 3 X's plus 6. 1, 2, 3, 4, 5, 6. Okay? The model 3x plus 2 has how many X tiles? That's these. There's 3 X tiles. And then how many little positive 1 tiles? There's 1, 2, 3, 4, 5, 6 of those. Okay, the model for 3x plus 6 has 3 X tiles, and then it also has 6 of the little positive 1 tiles. So are they equal to each other? Yes. They have the same number of tiles. Okay, I'm not going to write that out. So use algebra tiles to determine if 2 times x plus 3 is equal to 2x minus 3. So I'm going to make 2 groups of x minus 3. So there's x, and these were the little minus signs. Remember, you're just watching. Okay, and I needed 2 groups of those. So here's another one, and another. Okay, so there's x and then minus 3. Okay, and is that equivalent to 2x minus 3? Okay, let's draw 2 x's and then 3 negatives. 1, 2, 3. Is it the same? No, it isn't. This one only has 3 that we're taking away, and this one has 6 that we're taking away. This is just some more listening, okay? I'm going to explain these properties because you are going to have to know how to use them even if you don't remember the name of them. Some things you need to remember. That the commutative property, commute, means to move. If you go to a commuter college like Pan Am, that means that you don't stay there in the dorm. You travel from your house to school. You commute, like people commute to work. They move. They don't live at the place they work, usually. Okay, so that's what this means. You're moving these, you're switching places with them, and they're still equal to each other. So if you had 3 plus 4 and you switched places, put the 4 first, it's still going to be okay. That's the commutative property of addition, and there's a commutative property of multiplication. Okay, same rule. You can multiply in any order and you get the same answer. The associative property of addition means that you might have the same numbers, but when you follow the order of operations and you do the parentheses first, as long as it's all addition, you're going to get the same answer. Here they put the parentheses around the first 2 numbers, and here they put parentheses around the last 2 numbers, but they're still equal to each other. And that means that really you can add in any order. There's also an associative property of multiplication. Same thing, multiply in any order as long as it's all multiplication and not some division and other operations mixed in. Distributive property means that, oh man, you guys learning this? I didn't learn this till I was a freshman. See how it's 6 times because it's right next to the parentheses. That's 6 times and then everything in the parentheses. Well, you can break it apart. You can take 6 times 2 and then 6 times 4 and get that answer. And that'll be the same thing as adding inside the parentheses first and taking your answer times 6. Same thing down here. You can take 8 times 5 and get that answer and then subtract whatever 8 times 3 is. And you'll get the same thing as if you just subtracted first and took your answer times 8. So that's the distributive property. The identity property of addition means that identity means that this is going to be the same. Okay? So what do you add to any number to keep it the same? Nothing. What about multiplication? What do you multiply to a number to keep it the same? 1. And then the inverse property of addition means that when you add a positive to its negative, you're going to equal 0. So like 11 plus negative 11 equals 0. That's the inverse property of addition. Okay, so use a property to write an expression that's equivalent to x plus 3. Okay, so use a property. So we want something that's equal to x plus 3. That is equal to 3 plus x. Okay, and the property that I used was a commutative property. Okay, now let's look at this last, like this, your turn here. For each expression, use a property to write an equivalent expression. Tell which property you used. So I'm going to take ABC, and instead of multiplying A and B first, I'm going to multiply B and C first. Now what was the name of that? Ah, here it is. The associative property of multiplication. Okay? The associative property of multiplication. Okay, 3y plus 4y. Okay, I'm going to use a distributive property for that. I'm going to take out y and then put in 3 plus 4. Okay, remember the distributive property means that if you take y times 3 and y times 4, you'll get the same answer as if you put them together. I don't know if that's one they really had in mind for us to use. We could do it like this. 4y plus 3y. We just switch places with them, and that's it. Okay. So let's go ahead and set up our Cornell notes. And it's whatever the date is, 1/26/15. And the title of this is, what is it? Let me look for it. Okay, generating equivalent expressions. Any questions that you have, write them over here. And then let's take some notes. Okay, let's do your turn, number 5. It says use the properties of operations to determine if the expressions are equivalent. Okay, so let's put number 5 here. 6x minus 8, and then 2 times 3x minus 5. Alright, so if we will use a distributive property here, 2 times 3x, that's equal to 6x. You have 6 x's. If you have 3x 2 times, that's 3x plus 3x, that's 6x. Now let's take 2 times 5. That's 10. And then right here in the middle, we have subtraction. Is that equal to that? No, those are not equal. Okay, let's look at number 6. 2 minus 2 plus 5x. 2 minus 2 plus 5x. And they're wondering if that is equal to just 5x. Is that equal to each other? Well, this right here is that property where they cancel each other out. Okay, so you can go back to that list and see. And when you have 2 minus 2, they cancel each other out. That equals 0. All you have left is 5x. So yes, and that was called the inverse operation of addition. or inverse operation. Okay. Last page. This is one of my favorite things to do. It's been a long time since I've had to teach it. When I was a 7th grade math teacher, I taught this, but I haven't had to teach it in a long time, but I love to do it. You look for things that are the same. Like this has that x squared, and this has the x squared. So that makes these like terms. We studied terms in our vocabulary lesson part of the module. Terms are separated by addition and subtraction signs. So here's one term and here's another term. And like terms have the same like variable with the constant. Okay, and it tells you 6x squared and 4x squared are like terms. They look alike. The only thing different is the constant. The constant are the numbers. Okay, so don't worry about the term. Let's just look at the constant. What is 6 minus 4? It's 2. It's right there. And then just keep the x squared the same. This was really complicated the way they did it. Just take 6 minus 4, which is 2, and then keep your term the same. Excuse me. For B, oh, I didn't tell you what to write down on that one. Let's look at B. Write down 3a plus 2b plus 5a. And what we're going to use is the distributive property. So we're going to take 2 times b and 2 times 5a. Goodness, I need a drink. All right, so here we have 3a plus, now what do you get when you take 2 times b? It's just going to be 2b. And 2 times 5a, what's 2 times 5? 10. And then there's an a. So if you have like 5 a's and you double it, that's going to be 10 a's. And then your plus sign will just stay the same. Now you can see which terms are alike. We have a's here, and we have b's. You can't add a's and b's together. Okay, so let's see how many a's we have. 3 a's plus 10 a's is 13 a's plus 2b. We don't have anything to add with that 2b. So it's just going to stay like that, and you can't add 2 a's and b's together. So that's your answer. All right. Sometimes you will have variables in your answer, and that's okay. All right, let's write down C. Y plus 11x minus 7x plus 7y. So anything that has a y in it, let's put it together. Let's combine like terms. So here's a y, and here's 7 y's. So what's 1 y and 7 y's when you put them together? It's 8 y's. Notice there's no 1 in front of this y, but there's still 1 y. So they think, well, if there's only 1, just writing one letter y is fine. Okay, so we have 8 y's. Now, we have this right here, 11x minus 7x. So if you have 11 x's and you take away 7 of those x's, what do you have left? You have 4 x's. Do you have positive 4 or negative 4? You have positive 4, so plus 4x. And there's your answer. Beautiful. Okay, continuing on your paper, write number 8. 8y minus 3y. So you have 8 y's and you take away 3 of them. That gives you 5 y's. Okay. Let's go to number 9. We're looking for like terms, but do you see that 4, how it's next to the parentheses? We have to use a distributive property to separate those. So what's 4 times x squared? 4x squared. And what's 4 times 1? It's just 4. So let's rewrite this problem after we have the distributive property. Here's number 9. Okay, this is a term right here. Just write it down. Okay, now what did we say 4 times x squared was? 4x squared, so plus 4x squared. And what did we say 4 times 1 was? 4. And then to separate these two terms, just use whatever's right there, minus. Now we can see what terms are alike. Here's x squared, and here's an x squared. You have 6 x squares here and 4 x squares here. How many is that altogether? 10 x squared. And then this right here is all by itself, so you just write minus 4. There was nothing to put together with that one. Number 10 is a little bit easier. A to the 5th power, there's 4 of those here, and we're subtracting 2a to the 5th powers. So 4 minus 2 is 2, and then you just leave that variable alone with the exponent. You don't add or subtract those. Now here we have 4 b's, and we're going to add a b to that. So that together is 5 b's. Everything's positive, plus 5b. Okay? Remember, you're looking for like terms. Here's 8m. Do you see any other m's? No. Okay, here's a 14 that is just a constant without a letter, a variable. Here's a 12 without a variable. And here's a 4n. That n does not match anything either. There's no like terms. You can't put the m and the n together. They're different terms. Okay, so what do we have? We have 8m. And then what is 14 minus 12? 2. It's positive 2. So 8m plus 2. And then that n is all by itself, so plus 4n.